Good morning, students. Today I will discuss about periodic properties. Periodic properties. Listen. Periodic properties. See, what are periodic properties? Periodic properties means the properties which are change gradually with the change in electronic configuration between two regular intervals. It is called periodicity. That properties are repeat itself between two regular intervals are called periodic properties. What are periodic properties? Atomic radius is periodic property. Ionization potential is periodic property. Electron affinity is periodic property. Electronegativity is periodic property. Electropositivity is periodic property, etc. What are the periodic properties mean? The properties which are change gradually with change in electronic configuration. This change repeats between two regular intervals. That repetition is called periodicity. The properties are called periodic properties. Understood? The properties which are change gradually with change in electronic configuration between two regular intervals. This is repeats itself between two regular intervals. That repetition is called periodicity. The properties are called periodic properties. In that periodic properties, the first one is atomic radius. Atomic radius. See, atomic radius. What is atomic radius? The atomic radius means, for example, take copper. See, copper atom, copper metal, another copper atom, two copper atoms. Here it is one copper, here another copper. From here to here, see, check. This is nucleus, center of the copper. This is another nucleus, another center of the copper. See, it is the distance between the two centers of the two nucleus of copper atoms. Then what is atomic radius? See, atomic radius means it is known as atomic radius R. And here it is atomic radius R. Atomic radius of the copper. See, atomic radius means generally it is the distance, it is the half of the distance between centers of the two nucleus. The half of the distance between centers of the two nucleus is called atomic radius. Understood or not? So here, for example, take another example also there, another point is also there. Atomic radius means, for example, take sodium. Sodium atomic number 11. It is 1s2, 2s2, 2p6, 3s1. If we take sodium atom from the nucleus, first shell, second shell and third shell. See, here third shell means 3s1. It is first shell 1s2. It is second shell 2s2, 2p6. It is third shell. So third shell is known as valence shell. The last shell is known as valence shell. Here third shell is known as valence shell. See, what is atomic radius from for sodium metal? It is exactly distance between the center of the nucleus and valence shell of atom. This is known as radius, atomic radius. It is the distance between the center of the nucleus and outermost orbit of an atom. Outermost orbit of an atom, it is also known as atomic radius. Based on this condition, we can explain the size of atom. See, it is sodium atomic radius, then size of sodium also same. The size of sodium also same. Another important point, what are the units of atomic radius? Units of atomic radius, that is units of atomic radius angstroms. Because it is very small, it is expressed in angstrom. 1 angstrom is equal to 10 power minus 10 meters. 1 angstrom is equal to 10 power minus 10 meters. The atomic radius of atom explained in angstroms. 1 angstrom is equal to 10 power minus 10 meters. Understood? This is about atomic radius. And but based on the bonding between two atoms, the atomic radius are divided into different types. Now, types of atomic radius. Listen. Types of atomic radius. Types of atomic radius. And the types of atomic radius is 1. Covalent radius. 2. Metallic radius. The metallic radius is also known as crystal radius. 3. Van der Waals radius. Van der Waals radius. See, based on the nature of force or bonding between the atoms, the atomic radius are divided into 3 types. That is 1 covalent radius, 2 metallic radius, 3 van der Waals radius. In the case of covalent radius, for example, take F2. Take F2. Fluorine, it is one fluorine atom. It is another fluorine atom. See, because gases overlapping takes place. Both are gases, then overlapping takes place. So, it is the bond between two fluorine atoms. Two fluorine atoms are non-metals. Understood? Non-metals forms covalent bond. Non-metals forms covalent bond. See, what is covalent radius? Covalent radius means it is the half of the distance between centers of the two atoms. It is the half of the distance between centers of the two atoms is known as covalent radius of fluorine. Understood? Because these atoms are bounded by covalent bond. These atoms are bounded by covalent bond. Understood? These atoms are bounded by covalent bond. What is covalent radius? It is the half of the distance between centers of the two nucleus which are bounded by covalent bond or is known as covalent radius. In the case of covalent radius, the covalent radius always, see, covalent radius always less than atomic radius. The covalent radius always less than atomic radius. See, because atomic radius is more. Why atomic radius is more? For example, if you compare the atomic radius, see, from atoms, see here, from here to here, it is known as atomic radius. Understood? See, listen. For example, take from here to here, it is atomic radius. But covalent radius up to here only. Covalent radius. Which is more? Covalent radius is more and atomic radius is more. See, covalent radius is more. Because if you observe, this is known as, covalent radius is less. Atomic radius is more. Because atomic radius is more, see, this is excess for atomic radius. Understood? This is known as about atomic radius. And from here to here, it is atomic radius. From here to here, it is covalent radius. Which is more? Atomic radius is more. The atomic radius always greater than covalent radius. Understood? Covalent radius is less than atomic radius. This is the first one. So, what is covalent radius means? it is the half of the distance between centers of the two nucleus which are binded by covalent bond. It is known as covalent radius. So covalent radius is completed. Now second one is metallic radius. Listen, the second one is metallic radius. The metallic radius means metallic radius. Second one is metallic radius. Covalent radius is completed. Now about metallic radius. See, metallic radius is also known as crystal radius. Crystal radius. So generally it is the, take two metals. One is copper, another also copper. Copper metals. It is copper, it is copper. Understood? Now it is the half of the distance between centers of the two metals is known as metallic radius. It is the half of the distance between centers of the two metals which are binded by metallic bond. It is called metallic radius. In the case of metallic radius, if observed, metallic radius is equal to atomic radius. Metallic radius is equal to atomic radius. This is the one point. Second point is less metallic radius. Metallic radius is indicates strength. Metallic radius is less means the distance between two metals is less. It forms a strong crystal. Strong crystal. The strength of the metal is more. The strength of the metal is more. The less metallic radius, more metallic strength. More metallic strength. The less metallic radius, more metallic strength. More metallic radius, less metallic strength. More metallic radius, more metallic radius, less metallic strength. See, based on metallic radius, we can explain the strength of the metals also, because less metallic radius means they occupies less distance and more metallic bond is there. More metallic bond is there. See, metals are heavy metals are compressed. Heavy metals occupy less distance. So for example, if distance between two metals is less, the metallic bond strength is more because attraction is more. Because of attraction, they exhibit strong bonds. They form strong bonds. Hence, it is very difficult to separate one atom to another atom in the case of less metallic. And in the case of more metallic radius, they are exhibits less strength. So based on that, metals are two types: soft metals and hard metals. Soft metals means these are known as soft metals. More metallic radius means less metallic strength, that is known as soft metal. Hard metals means less metallic radius, they are more metallic strength. But here the atomic radius is always equal to metallic radius, because if you observe this, see what is metallic radius. See, from here to here it is known as metallic radius. What is it is atomic, it is metallic radius. What is atomic radius? Similarly, it is here to here atomic radius. So both are equal. Metallic radius is equal to atomic radius. This is about metallic radius, 2 completed. And now another one is known as crystal radius. So metallic radius is also known as crystal radius, and last one is known as van der Waals radius. Van der Waals radius. See, generally van der Waals radius means it is explained for solid state molecules only, which are generally van der Waals radius expressed for noble gas elements, solid state molecules and monoatomic gases, like that. For example, take 2 chlorine atoms. This is chlorine and chlorine, Cl and Cl, chlorine molecule. And here the centers. So this is known as covalent radius. And write another chlorine molecule. Write another chlorine molecule. So this is Cl and Cl. But these two chlorine molecules from here to here, it is known as covalent radius. See here, the covalent radius is, it is covalent radius. It is also covalent radius. Up to here it is covalent radius. But these two chlorines are attracted by some attractive forces. That attractive forces are called van der Waals forces. If chlorine molecules present in solid state, the molecules occupy very less distance. Why they are exhibits very less distance? Because they have attractive forces. That attractive forces are called van der Waals attractive forces. That attractive forces are called van der Waals attractive. See, these two molecules are attracted by van der Waals attractive forces. Hence, what is van der Waals radius? It is the half of the distance between centers of the two nucleus. See here to here, this is called van der Waals radius. Van der Waals radius. It is the half of the distance between. It is van der Waals radius. It is van der Waals radius. From here to here, van der Waals radius. It is the half of the distance between centers of the two nucleus of two different molecules which are attracted by van der Waals attraction forces. Van der Waals attraction forces, that is called van der Waals atomic radius. See, if you observe, van der Waals radius is always greater than atomic radius. Van der Waals radius is always greater than atomic radius. The van der Waals radius is always greater than. Why? Because see, what is the atomic radius here? If you compare the atomic radius from here to here, it is atomic radius. What is the van der Waals radius? See, from here to here, van der Waals radius. See, van der Waals radius is very high when compared to atomic radius. So, van der Waals radius mainly expressed for solid state molecules only. Van der Waals radius mainly expressed for solid state molecules only. Understood? See here, if you take 3, van der Waals radius is greater than atomic radius, metallic radius is equal to atomic radius, metallic radius is equal to atomic radius, metallic radius is atomic radius, and covalent radius is less than atomic radius. Covalent radius is less than atomic radius. Based on these three, van der Waals radius always more. Van der Waals radius is always greater than metallic radius. Metallic radius is always greater than covalent radius. See, least radius is covalent radius. According to order, van der Waals radius is greater than metallic radius is greater than covalent radius. This order is important. Understood? So, today in this class discussed about one periodic property, that is atomic radius. The atomic radius are 3 types, that is covalent radius, metallic radius and van der Waals radius. Okay, today's class completed. Everyone read your material and see the all class, and after that read once in your EDUHUNT material. Okay, tomorrow I will discuss about the objective bits about radius. Okay, good day everyone.